This is Manan from Mood Data Scientist, and in this video, we are going to learn about VIF. We are going to talk about VIF, how we can calculate VIF, how to interpret the VIF values, and how we can perform it. So let's move forward. So first of all, what is VIF? Variance Inflation Factor is a measure used to identify the severity of multicollinearity in multiple linear regression model, and how we can calculate VIF. In order to calculate VIF, there are three steps. First, we need to learn linear regression. And then we need to calculate the coefficient of determination, or we can say I square for the regression. And then we need to compute the VIF values for using the formula 1 upon 1 minus R square. Now let's move forward and see how we can interpret the VIF values. So basically, when VIF is equal to 1, we can say that there is no multicollinearity. When the VIF values are between 1 and 5, we can say that there is moderate multicollinearity. But when the VIF values are greater than equal to 5, we can say there is high multicollinearity, and we need to address the problem. Now let's move forward and download our data set. For this problem, the data is for the purpose of bias correction for the maximum and minimum air temperature. Let's have a look at some of the attributes. So we can say that we have station, date, present Tmax, present Tmin, lat lon, slope, and much more. So now we are going to download the data set. We are going to do that using a pandas data frame, and we are using the method read CSV. This is the URL from where we are getting the data. Then we are going to drop any rows where there is any null values, and then we are also going to drop the column date using the drop method. Now let's move forward and run the code. It might take a couple of seconds to download the dataset. So this is how your dataset looks like. Overall, we have 24 columns and around 7,500 rows. Next, what we are going to do, we are going to import all the necessary libraries to perform VIF. So we are going to import variance inflation factor from the stats model. So this is how it is done. Now we are going to run the code for this. Once it is done, we are going to select the data frame. So over here, what we are doing, we are selecting all the columns except the target column, that is next min. And then what we are going to do, we are going to separate our target column from the dataset using a pop method. Now it is done. Now we are going to perform VIF. So what we are going to do, we are going to save the values of VIF in a data frame. Then we are going to sort the values of the data frame using sort values. So now let's have a look at the code. Here you can see that we are creating a data frame known as VIF-DF. And then we are creating a column called as VIF, and we are calculating variance inflation factor on that column. And then we are also saving the name of the attributes and calling it as attributes. Then we are going to sort the values in descending order. Now let's run this code. This code might take a couple of seconds depending upon the size of your data set as well as the number of cores you're using. So this is the value of the code after running. So we can see that lat and lon have the highest VIF values. So moving forward, there are two strategies that we can apply for this. The first one is removing all the attributes at once where VIF is greater than 5. But if we go through this procedure, we might lead to more loss of information. The second one is removing the attributes where VIF is greater than 5 one by one, and then calculating the VIF again. With this strategy, information loss is minimized. Remove all the attributes one by one. We are going to use a while loop. Keep removing the attributes from the data frame where VIF is greater than 5. Now let's move forward and see the code. So here you can see that we are using a while loop. Then we are creating a data frame, and then we are creating an attribute known as VIF, and we are calculating the VIF for that column. Then we are also taking another column, calling it as attribute and saving the name of that column. Then we are sorting the values of VIF in a descending order. Then we are using an if-else loop. If the value of VIF is greater than 6, then we are printing that value and removing that from the data frame. And otherwise, we are just breaking the loop. So what we can do, we are going to run this code. This code might take a couple of seconds to run. So as you can see that the code is working. Overall, we can see that first the column lat has been removed because it is having VIF values of 652,744. Then we are removing LDAPS, Tmax. Then we are removing lon. So now the code has run properly. Running the code above, we can see that we have removed a total of 13 attributes where the VIF value was greater than 5. Now what we are going to see all the remaining attributes. So these are the attributes remaining and their VIF values. Now what we are going to do, we are going to create two models. In the first model, we are going to train the model with all the attributes and then we are going to check the mean square error. In the second model, we are going to train the model with the attributes where VIF less than 5, or we can see that all the attributes in this data frame. Now let's move forward with our first model. Over here, we are importing all the necessary libraries. We are importing standard scalar, train test split, linear regression, mean square error. Then we are going to split the data set into training and testing. Then we are moving to data engineering part in which we are going to normalize the data. For that, we are using a standard scalar. We are going to transform the training set as well as the testing set. Once it is done, we are going to implement a linear regression model. We are going to train the model with the training data, and then we are going to make some prediction and calculate our mean square error. Now let's run this code and see our mean square error. So running this code, we can see that we are getting a mean square error around 93%. Now let's go move forward and train our second model. So in this, we are going to train the model with the attributes where the VIF values is greater than less than equal to 5. So all the procedure is same. Over here, you can see that we are just taking the attributes where VIF values are greater than less than 5. So now let's move forward and run this code too. So as you can see that the mean square error has been increased a lot. So make a note of this. This might depend on the type of machine learning algorithm that you're using and the data set you are using. So in order to get proper results, you need to run the code a couple of times. So now let's have a look at the summary, what we have learned about. So we have learned about VIF, how we can calculate the VIF, how we can calculate VIF values, how we can perform VIF using a machine learning model. If you have liked the video, please subscribe to the channel